Well, with that said, I would like to continue further on our presentation with our partner Polski Rejestr Statków, and I would like to invite Mr. Marek Narewski to give a presentation on selected aspects for safe use of alternative fuels on small vessels. Mr. Narewski, if you can hear us, please do your presentation. Thank you. Yes, we can see the presentation now.
Unmute. Yeah. Do you hear me? I think. Yeah.
Yeah, we can see the presentation. Just if you are able to make it on full screen, that would be great. Yeah, thanks. We got it now.
Yeah. So once again, good morning. Thank you, organizers, to have a chance to create a chance for us to tell a little bit about alternative fuels, about hydrogen, about small vessels, and some safety aspects. Polish Register of Shipping, I think if Polish customers are quite well familiarized with PRS. I don't know whether we have some people from outside Poland, but anyway, data about the PRS could be found on the webpage. We are classification society, Polish classification society, working in a global market together with 12 other classification societies. We are member of IAX. We are having a set of authorization from flag states. It's about 40 right now. We are recognized by European Union for inland waterway transport certification classification, and of course, because trends are as we know are, so we are working also on introduction of regulations on safety issues related to alternative fuels, and this is what I'm going to tell you a little bit about. Presentation is small. It's taking about 20 minutes, so I think it's not enough time to talk about all the issues related to safety. What I'm particularly interested right now is to provide you with some introduction to issues related safety of small vessels. Small vessels are vast part of international and domestic shipping. People familiar with ship construction know that around the world we have around 1,000 seagoing ships, but the number of smaller ships which are not SOLAS classed, so it's well, hundreds of thousands small ships. So recent research showed also that pollution from small ships is quite big. I do not know the figure, but it's a quite important issue for harbors, for authorities, for communities which are sitting around the shore. So my presentation will touch a little bit to rules, regulation issue, which is very important to set the design of a ship to be operated, to be certified with safety in mind, because no one is interested to have problems, and failures and disasters are not doing well for anyone, and social reception is of course very negative. And some comments on propulsion, on some case studies we are familiar around about the alternative fuels. We start with something which is to imagine you a little bit, what does it mean small ship? Small ship or craft, we normally understand it's something small with regulatory matters, it's with length below 24 meters. Of course, this is something which could be discussed, but to define if the ship is small, we have to take into account length, draught, beam, We can consider size, we can consider propulsion and some additional issues. Of course, number of crew passengers could also be kind of sign distinguishing between if ship is smaller, bigger, or anything like that. So from safety point of view, on a small ship, what we have critical, it's first of all, it's basically lack of space. We can have problems with weight and buoyancy. We can have problems with satisfactory solution to protection in fire matters. We can have problems with the structure. And right now, because a very popular issue is construction of small ships from reinforced plastics, this is another issue very important for safety in case of alternative fuels are going to be used. So one very important remark, it's quite common that majority of small ships or craft designs are prototypes. So this is something which is to be taken into account because matters of safety must be very detailed considering. Must be attention given to safety issues is very important, and it has influence on final certification and possibly the additional requirements which are going to assure safety of the ship in operation. Definition of alternative fuels, it's something which was defined by European directive, and basically means that alternative fuels means fuels or power sources which serve at least partly as a substitute for fossil oil sources in the energy supply to transport means, and which have the potential to contribute to its decarbonization and enhance environmental performance in the transport sector. What does it mean? It means that alternative fuel is electricity, is hydrogen, biofuels are considered as alternative fuels, synthetic fuels. One of the synthetic fuels is maybe very not well known is dimethyl ether. We have a case study on this later. Of course, we have natural gas, compressed natural gas or liquefied gas, and we have LPG. In the green color, I tried to distinguish the fuels which have some maturity potential, which allow easier application on smaller craft. Some examples, I think for many people interested in ships are very well known. This is Pusher, which is a project in Germany, quite advanced with use of hydrogen. This is Alster Sea, small passenger craft with fuel cells, which was constructed over 10 years ago. And small craft for Netherlands, Rotterdam, as far as I remember. So this is basically what the small ship is looking like. Some guidance, what we have to take into consideration. First of all, if we have to have fuel on board, we have to consider what is the way to convert this into energy which is used on board. So storage of the fuel is the one issue, conversion means the other issue, and conversion into propulsion or into hotel purposes is also another issue. So for designer, as Mr. Czerski showed, not only the electric diagram is important, but also all other systems related to conversion of the fuel into usable waste, in the usable energy which is consumed on board. Regarding the regulations, rules, because everything which is being designed and is to be constructed later needs some survey of a construction and finally certification or classification, because to have ship to be operated, we have to have documents. So regulations are very important. And basically, we have two sets of regulations. One set concerns IMO, which is governing body for international shipping. And such major document for this is IGF code, which allowed to use fuels with flash point below 60 degrees to be used as propulsion means for seagoing ships. This document is very important because it provides basic safety solutions for the use of LNG. And right now, quite a long time work is going on the extension of the IGF code to include hydrogen. I don't know when it will be. We are involved in some works on this because of, as a member of IAX, we are working on assessment of some IMO documents. We are issuing our own guidance, but IMO IGF code is a primary document which was later incorporated into the classifications rules of any society. On the inland waterway side, we have European regulation. It's a directive on technical means for technical safety means for inland waterway ships. For right now, this document, which is quite fresh, 2 years old, I think it's concerning on the use of LNG. No regulations are included in for the use of hydrogen or other type of alternative fuels. I know that the work is ongoing, so maybe this will be completed in a coming year or next year. Concerning the alternative fuels, we have to consider hazards, we have to consider risk, and we have to elaborate mitigation measures. For I got the hydrogen case as quite interesting right now because it's a lot of information in the media, not very much on the technical side, but some problems which may arouse are related to the fact that hydrogen can ignite, and sensing the ignition of hydrogen is not so easy. So a lot of effort to prevent any problems is to be done on elaboration of protection measures, elaboration of passive fire protection, and of course installation for detection monitoring of hydrogen related compartment on board ships. Problems which could arise from use of compressed hydrogen are quite similar as with the liquid hydrogen, but one advantage for compressed hydrogen is that we can store it for a longer time in a storage bank or pressure vessels, while in the case of liquid hydrogen, if this is taken on board, it must be used. So any installation for optimization of the use of liquid hydrogen on a small vessel is not having chance to be implemented. Regarding some guidance on ship on construction for in case of the use of alternative fuels, I already mentioned that in case of small ships we have quite a lot of limitation. We have limited space on board. We have very limited size of machinery compartment. If someone would like to build a twin hull, place space in each of the hulls is very limited. So quite a lot of equipment is to be taken on the deck. Depth limitation could be a problem, particularly in case of inland waterway ships, and of course, case of LNG. Because IGF code imposes a lot of safety requirements for piping installation, for separation of the compartment. I'm not very convinced that every requirement from LNG, from IGF code could be implemented on a small ship. So it's a big role of designer, of certification authorities, classification society, if class is providing supervisory on the ship design and construction. As some summary of the safety principles, you can see something I put on this slide. Technical progress is, of course, much more effective if we have number of applications. If applications are single, one country, one application, another country, two applications, maybe completed projects, this is something which is very difficult to consider when we would like to use probability as a measure of assuring safety. So in the case of prototype ships, maybe the use of data from data and experience from automotive sector will be useful. And this is something which could be taken into account when new ship designs will be considered. However, automotive is using different materials. On both ships, we have quite different situation regarding environmental issues. We have humidity, we have rolling, we have quite a lot of another issues which are related to the fact that not everything is safe on board ships. So, as I mentioned, in case of vessels built from plastics, from glass-reinforced plastics, this could be a problem if you would like to place something which is risky from current experience. When we want to place it into a closed compartment, then we must assure right placement, right passive fire protection, right active means for firefighting, and sometimes maybe the solution will be to place all the machinery into something which is brought in solars as equivalency to steel. Plastic is not equivalent to steel. Steel has a limiting temperature point 925 degrees. In case of plastic, nothing will stand longer than if temperature will reach over 150 degrees. Potential problem also for design and certification is right design process, right as evaluation of energy demand, and of course potential problems. We know that on board ships we have main power, we have auxiliary power. So in case of any application of alternative fuels, this must be taken into consideration as well. Right now, I would like to provide you some information about the interesting projects with alternative fuels. One is, as I mentioned, DME, and another is methanol alternative. What you see in this picture, this red boat is something which was built in Sweden. It's a pilot boat which is using methanol as a fuel. On the lower slide, you see a yacht. This yacht is constructed. The yacht is Polish one. It's a floating laboratory of Gdańsk Technical University. And the interesting point is that it was converted to use DME as a fuel. So in this case, project was completed by mechanical department of Gdańsk Technical University. Full set of risk analysis was done. Typical yacht engine was converted to use DME. A lot of additional measures to have continuous monitoring of condition of the fuel system and all security systems. And on the right side, you see how the problem of storage of DME was solved. DME properties are very similar to LPG. So because this is a kind of experimental craft, two LPG tanks are fitted in the rear part of the yacht. And we did certification of this boat, and its primary use is for research. But it shows that there is potential in Poland, in particular in Gdańsk, to consider something which is experimental and could have a positive effect on possible practical applications. As mentioned earlier, this Swedish pilot boat is using methanol, and it shows how the solution for storage of methanol was showed. This is bunkering. On the lower slide, you see bunkering station. On the upper slide, you see tanks. Tanks are, of course, made of stainless steel. Everything is done to have ability to use it in a safe way. As you know, methanol is fuel with flash point below 60 degrees. So a lot of concern was put on safety in this case. We were talking about, or you were provided with some information about the liquefied hydrogen, about the compressed hydrogen. Of course, designer will decide which type of fuel will be better for the certain project. What I would like to show on this slide is how we are able to store compressed hydrogen on board, because such project for pressure vessels to be potentially used for compressed hydrogen was conducted in Poland. There were some composite pressure vessels designed and were type approved for another application, but it's quite popular that type 3 pressure vessel is used to transport hydrogen, because it's a lot of advantage due to weight of the cylinder. Of course, you can use a metal cylinder type 1. You can use type 4 cylinder, which is something of quite similar design as type 3, but the liner inside is made of plastic. In a cylinder type 3, the metal liner is made of metal. So it's much better in case of potential protection about hydrogen embrittlement and permeation, which could be a problem. The safe place for hydrogen in this case, but some guidance could be taken in case of other low flash point fuels. As earlier was talked, placement of hydrogen cylinders on a pusher. This is the best place, because we have shallow draught, machinery is put forward, azimuth drives probably are placed over there. So this allows to put hydrogen banks, hydrogen containers on board. Refueling could be done quite easily by exchange of cylinders. In case of another vessel, which is TAG, which is under construction in one of the Benelux countries, hydrogen storage is placed under the deck over there in the rear part of the vessel. In case of this vessel, which was one of the first vessels successfully completed and operated with fuel cells in Hamburg for a couple of years, hydrogen cylinders were stored in the bottom part of the vessel. What is interesting with that vessel is that suffered fire some years ago. Fire was quite disastrous, and all the infrastructure was destroyed, but nothing happened to the cylinders. So it's one of the cases I'm familiar that fuel cells and hydrogen could be quite resistant to potential problems. As conclusions, what I would like to point out that in case of alternative fuels, we have a different situation. We have to put more attention on design. Design could be more complex. It's not the same situation as we have with in case we have with traditional fuels. Diesel engines are used on board ships over 100 years. And right now, the statistics is that every year, if someone will consider accidents on board ships, about 30% are fires. What it will be with alternative fuels, I do not know, of course. But identification of potential problems is a prime task for the designer. Identification of problems with insufficient propulsion on early stage of design is another issue, because if we consider electrical power as a alternative fuel, someone who is future owner of the ship is interested in having the lowest price. So it could be stressed. A designer could be under stress to select lower power. But we did a study on this issue, and especially in some the smaller inland crafts, it happened quite often that propulsion power was too small to cope with environmental issues, because in case of battery, we have limited capacity. In case of construction, the underwater part is small, upper part is bigger. So if the power installed for propulsion is too small, ship could not be able to fight with the wind and with the waves. So it could influence on the final certification of the vessel, because allowed operational area could be drastically shortened. Well, I think that the very important is the ability to discuss with regulatory bodies the issues. Right now, maturity of technology concerning hydrogen is not same as with diesel engines, where it's a lot of gaps, it's a lot of information which is kept by designers of the vessels, because designers by the ship equipment. So to get finally the safe design, I mean, the open discussion with certification body, with classification society is necessary. And I recommend this is to be done as early stage as possible, because we know quite a lot. And this knowledge could be for benefit of future design. It's, I think, the final conclusion. In case you have questions, in case you have some problems, when possibly we can support you, I recommend to turn to Polish Register of Shipping. My contact data are in the end of this presentation.
Thank you, Mr. Narewski.
In case of questions, you are welcome.
Thank you for the great and in detailed presentation about Polski Rejestr Statków partner. It was really great to see the point of view from the shipping side, what are requests, what it needed to and how they can be met by the small vessels. Excellent. As we are a bit in front now and we are short on time,